Hey guys, so we're continuing in section 3.2. Okay, some more 3.2 to go. Okay, and this is going to be separate notes, so please take out a sheet of paper and you can kind of stick it in the middle of these packets. That way everything kind of flows for you. So we're going to be using these regression formulas. This is all messed up. I mean, I have the best intentions when we try to type this out. And I had an intern, a fantastic intern, by the way. She was awesome. My first one, Emily Blair. She's fantastic. She's now my first intern is actually. She went to school for statistics because she liked it so much, and she's working in Worcester in a job now. She graduated from UMass. Okay, had a major in biostatistics. Okay, so she's actually using the stuff that we do. She asked me if I knew anybody that would want to work for her, and I don't know, I just don't have anybody right now, especially the school year started. So this doesn't really line up, but we want to write this in your notes. This is going to be important, okay? This is going to be important. This is going to be easy. For those people that liked the algebra part of things, okay, this is going to be like that stuff, okay? And we're going to be referring to our good old formula sheet here. Okay, so the formulas that we're going to use are right here, which is y hat equals a plus bx, where b stands for my slope, okay, and a is my y-intercept. And then this one here, which is y bar, is equal to a plus b times x bar, okay? And which is written right here, and then the other formula which says b equals r times the standard deviation of y divided by the standard deviation of x. Those are s's. Okay, those are s's. Okay, and it shows it right here. Okay, so these are the three formulas that we're going to be talking about right now. Okay, they're on your formula sheet. We're going to try to use consistent ones. Some of my notes have the old formulas, okay, so sometimes I might write the wrong formula down, and I apologize for that. I'll try to correct myself where appropriate. So the reason that they write them like this, okay, if I was going to graph this line, y equals 1/2 x plus 2, what do? Well, we go over here, we start at 2, okay, and then we go up 1 over 2, up 1 over 2, and you make your line. So in the statistics world, they think it's smarter to write the intercept first. So that's why that's your y-intercept, and that's your slope. That's why they do that order. That's just, those people think it's, you know, statistics people tend to think they got all the answers to the world's problems. So that's why they write it that way, okay? And so let's look at this formula. Okay, let's look at this formula and let's look at this formula. If you think of an XY chart, okay, and I want to tell you what these things mean, okay? If you're considering an XY chart where this is your X and this is your Y, where this is your explanatory and this is your response, and you have all these values, 1, 0.7, 0.8, whatever, okay? And you got the same thing over here, 75, 37, whatever. If you took all of these and you averaged them up, you would get X bar. You would have the average for X, the average of the X list. If you averaged all your ordered pair Y values, that would be Y bar. And that's what those stand for, okay? Now, these two, okay, the SX is your standard deviation of your X values, standard deviation of X values, and SY is your standard deviation of Y values, okay? Your average distance from the mean, average distance from X bar, average distance from Y bar. That's what those two things are, okay? So if I'm thinking about what this is, and B stands for my slope, then the slope is related to the difference of the standard deviation of Y and that over the standard deviation of X. But you can't just say the slope is equal to the standard deviation of Y over the standard deviation of X. It's not quite that simple. I don't go up an entire SY for this, okay? I go up R standard deviations of Y for every one standard deviation of X, if that's the way you want to think about it, okay? So R is related here. R comes into play, okay? So you know, this has got to be similar when we had problems like this. When you had y equals mx plus b and y equals, they give you a point 2, 3 or 2, 3, it passes through and your slope is 5 and you'd go in and plug it in. We're going to be doing the same type of stuff as that, okay? The same type of stuff, except we're going to be using these summary statistics. So again, the formulas are the same. I've got my formula sheet here ready. We're going to still use that same example where that's my homework average and that's my test score. And my X bar, my average of my homework average is going to be 50. Boy, I'd be stunned if that happened. Oh man, I'd be ready to quit. And my Y bar, my test average is 70. That can happen. That can happen in some classes, some of my classes. Lousy ones, okay? There's my standard deviation of X. There's my standard deviation of Y. Okay, and let's just say that R is equal to 0.75. And they want me to make a model. They want me to make a model. They want me to make a regression line. And remember, a regression line is y equals a plus bx, okay? And the other two formulas that I'm going to use are on the formula sheet, okay? And it's y bar equals a plus b times x bar, and b equals r times the standard deviation of y over the standard deviation of x. So I need to use these two to get to that, okay? So this is what I want to end up with, and this is what I have. So I want to see which of these that I'm going to start with. Well, I want to find A and I want to find B, okay? But I don't know I don't know both of those right now, so I can't start with this formula. Let's see if we can start with this one. B I don't know, but I know my R, I know my standard deviation of Y, and I know my standard deviation of X. So I can use this formula. I can get an answer there. Here I'm going to have two unknowns, so I can't start there. So let's find out what our slope is. So B equals, my R is 0.75 times the standard deviation of Y, which is times 8, divided by standard deviation of X, which is 5. So we go to our handy dandy calculator, all right? And we say 0.75 times, is that 8 or 0.8? I think it's times 8. Times 8, get an answer, divide by 5, and what do you know, 1.2. That was what we had for our slope earlier. You guys probably don't remember that, okay? So now I have this, but I have this. I still have to find A. So now I can use this formula. Y bar, okay? Y bar is 70. So I say 70 equals A, I don't know, plus B, 1.2, times X, X bar, and X bar they told me was 50. So I can find my equation now. I'm good. Okay, 1.2 times 50. 1.2 times 50 equals 60. So 70 equals A plus 60. Minus 60 minus 60. A is 10. Look at that. Y hat equals 10 plus 1.2 times X, where that is predicted test score, and this is homework average. Okay, we did it. We sure did it, okay? So, we want to predict our test score based on the homework. We can use that, okay? And we can use our formulas, okay? So we're going to do another problem, and we're going to see if the days absent can predict someone's GPA, okay? So we're going to get started with this stuff. I'm going to have you guys get moving on this, all right? So let's say we had this. Days absent. We want to see, is there a linear relationship between days absent and GPA? So if someone has 4 days absent, their GPA is 3.2. 12 days absent, 3.4. 23 days absent, 2.2. Okay, 14 days absent, your GPA is a 4. 4.0, pretty good GPA. 7 days absent, it's a 3.4. 36 days absent, what are you bothering for? 2. 74 days absent, my God. GPA of 1.7. No days absent, a 3.3. Okay, 9 days absent and you get a 3.8. 26 days absent and you get a 1.8. So if you were to graph these, okay, if you were to graph these, you would have some points up here and then some points down here, and we would expect a negative association that as the number of days of absent goes up, the GPA goes down. We would expect that, okay? We would, okay? So we want to find a line of best fit, okay? So what do? Well, we're going to do this on our calculator, okay? So I want you to take a minute, I'm going to pause the video, and I want you to put these into your X, okay, or your L1, and put these into your L2. And I'm going to show you how to do this with a calculator, okay? Pause in the video.